welcome to another PlayBASIC blog. I think this is episode 8. Just doing a very quick test of recording on a different system on my laptop this time. Hopefully it's coming out a bit better. It's hard to remember where we were last time, but generally we've been talking about the translation across, looking over the forums over here. Look at the update thread for 165. I think we've got about, so the last revision here is beta 24, which is really just build 24, you should think of it like that. And it reintroduces the translate mesh to scene, which is an undocumented command that takes a couple of structures that are undefined as well and treats them as a sequence of polygons and pushes them into the scene buffer so you can render them as part of your scene. That was the idea. It does work, and it's generally used in a handful of these kind of 3D pseudo 3D scene examples. I'll just try to bring one up, for example. Bit of a double there. Thinking of something along the lines of the PS3D demo, which I made an alternative video the other day. See if this will play and capture. This is what I wanted to test out. So this is the software rendering. It uses the translate mesh to scene support. We'll see how this goes. It's pretty short, so we've got 5,000 cubes in the scene, a couple of dragons, the demo is running on this laptop actually, but it still actually runs very well on my Athlon system as well, which is the standard test system I test everything on that PB is written on. Single core system, I think it's about, what is it now? It's over 10 years old. Okay, so the translate the mesh to scene renders each object in that scene, including the terrain at the bottom. They're all the same. You just define a set of points, then you define the mesh, and the mesh is just groups of faces. Each face has either 3 or 4 points that you're attaching to each other, and that's pretty much it. You need some UV coordinates as well, but okay, just have a bit of a problem there. So that particular 5,000 cube demo, it's based on, it's a kind of a cleaned up version of the terrain example that comes with version of PlayBASIC. It's been updated a little bit, but mostly to add a bit of an interface for creating those meshes and to take away the mystery of creating those things. But if you download the learning edition here and go into demos, you'll see that there's a 3D terrain demo in there, and that's the exact same code. For those people who are curious about that. Okay, so getting back to PlayBASIC, where we were last time, we just released, PlayBASIC 1.65C, and I think the last revision's about beta 26 or 27 that was released on the forums. It has a handful more optimizations that were added recently, and these are actually in the Fraser. So I know that the current build is 29, I should think, and it's replaced things like the FastCalc, which is a very unusual command anyway. I thought about removing it, to be honest, but I've kept it for legacy reasons. It's not that much to support it anyway. FastCalc is kind of a special, it's a way of doing expression where you don't actually have any precedence in the expression. You just give it, you give it your result variable. It has to be a float, by the way, and you have to have an assignment. and then you just give it your list of things that you want done. So you want A float multiplied by B float, plus C float. Normally the mult would be done first and then the addition, then the C would be added to the result of A times B. But in FastCalc, they're just done left to right. There's no precedence at all. So you can lay out your expression exactly how you want it. And the solver in the runtime is designed to be very limited. So it's a very limited scope solver. So I think all it has is addition, subtraction, multiplication, and division, of course, and some combinations of things like you can do very simple expressions with one variable in them. So might have a D variable here or something like that. Yeah, it's pretty restrictive. But the reason it was added was early on, the cost of executing any float operation was very high, and the runtime was quite slow. I mean, modern runtimes now are probably 10 times as quick as what PlayBASIC used to be, which is kind of astonishing when you think about it. So this would kind of be the expression here, but this whole expression would be solved and pass through the PlayBASIC's main runtime, and when you do that, you have a lot of overhead that's going on around it, which is why we introduced this kind of shortcut method here, where if you have one line expressions that you can lay in order, you could get performance that's better. Stop rambling about that now. Some other optimizations that were added. One that comes to mind was it will do things like, if you have cos angle, for example, and normally you have maybe a rate multiplied by radius or something like that if you're using polar coordinates. If you're not sure, by the way, too, I mean, this is what cos and sine are commonly used for. You would have new x equal, say, current x plus, we'll call that movement angle, that's probably the way. And speed is actually what we normally use this as, even though it is the radius for those math people. Those non-math people out there like myself. It's been a while since I've done heavy math. Not that this is heavy math, by the way. The terminology gets lost most of the time with me. Okay, so this is computing its position along its new position along the y-axis, and the angle here is provided in degrees, not radians. So it's just 0 to 360. 360 would give you the same angle. We might as well just have a quick look at that actually in action. We better slow this whole thing down. Set FPS to 20. We'll make a do loop. Bit of a do there, and a bit of a loop, and we'll call sync. Then what we will do is here we're computing. We're saying that it's current angle the current position of our character, which is what was really trying to get at, by the way. So I'll say it's 400, its initial x position. This will be 300, which should be the center of the screen initially. If we give this a random angle, here equals a random 360 possible degrees. If we give it, call the float version of random, it will return a floating point representation of that. So, and that can have fractional results there as well. we'll clear our screen. So a little loop here is going to be, we'll have to set our speed there as well. We'll set the speed to just 1 for now. And if we just draw a circle, traditional sort of crappy demo sort of thing to do. Circle C, new X, new Y. We'll give it a radius of, I don't know, 32, and we'll fill the thing in, and it can just be drawn in whatever the current ink color is, which by default is white. Let's try it out and see if we've made any mistakes. Oh, we did. Oh, we didn't give it a color, sorry. Circle C means that the user's providing the color, circle just defaults to. So the program's running, but the character's not moving, so what have we done wrong? It's actually this logic here. So we've got our current position here, we're computing a position where we're moving to from this old position. We're taking a step in whatever this direction happens to be. We might print these out so you can see what's going on a bit easier. New X, new Y. We'll print the movement angle. Print, what's it, movement angle, and print speed. So run the program again. So our position's not actually changing. Our position is different from our initial position where it was 400 by 300, but we haven't moved again. And this occurs because we're computing a new position. We're moving from this initial, our starting position, I should say. We're not resetting it. So what we could do is we could do something like this, where we go, let's change our current position after we've drawn it to here. And current Y. So we move the character, stored its new position in this new variable, and we have its old position as well. We might need that for some reason. In this example, we don't. We've drawn our thing to the screen. Now we're making our current position, or our old position, which is really our old position now, become the new position. So when we get around to the second time we're running a loop, we're going to move from where we were, where we just moved from, a little bit more, and each frame we execute, or each time this loops, it should move across the screen. Cool. It's actually working. Hit escape to break. We'll change our speed. Let's make it run at a speed of 2 pixels in whatever direction it's facing. Hit F5 to run again. Going down this time. Make it 10 for all we care. Yeah. Alright, we'll keep moving it. It'll keep moving forever, so we're not actually restricting this position. But I guess the point I was getting back to, by the way, is about the optimizer rather than how to use cos and sine. When the compiler sees this expression now, and this cos movement, and then it sees a multiply straight after it, it will actually replace those with the cos radius variant. And it does that because that's executed as one operation inside the runtime. So, excuse me, for those who are not aware, there's a command called cos radius which just does this whole process in one command. Yep. So the compiler actually sneakily replaces this stuff here and creates this. Because inside the runtime, that's a single operation. In this example, this makes no difference to the execution performance at all. It doesn't make any, but it does. if you were calling this thousands of times, then yeah, it will make a big difference. That's how you use polar coordinates, by the way, if you weren't too sure. Right. So I've added some optimization into those things. We've replaced FastCalc. I did notice there's a couple of other things still in the structure that are not really right. Because at the moment, here's what happens. We've got your source code is it's phrased and then it's compiled to bytecode. And what used to happen is that at the runtime, the VM used to execute the tables that the compiler was using for it. So the two things were pretty well, one was compatible with each other. So as long as the two structures were updated together, things will work generally pretty well. But of course, the more things you add and change and modify over time, those differences occur. So in this, what we've been doing with 165 is getting rid of that model. Is that now the VM, there's actually a step in here. We've got a step in here that converts the compiler byte code to VM byte code. And this builds the entire program, all of its data, everything it needs into one blob. And then this is passed to the VM, and the VM, we just have one pointer to the program, and it just runs that program, whatever it does. So in theory, you actually have multiple programs in memory if you wanted to have. Older versions of PB actually allowed this, but then it was taken out because it was it wasn't seen as a very useful thing. I guess these days, it doesn't give you a thread, by the way. It's not how threading works. It's just time sharing. So what you could do is you could have, if you had two programs in memory, you wanted to run them together, you could run one program for so many instructions, and then the VM would stop and come back, and then we'd move to the next program and just do the same thing. Depending on how complicated the two programs are would depend on how well that works. If you've ever seen the Kairos demos, just trying to think where that was now. I think it's in here somewhere. Yeah, it's not in the first page, so I don't know where it's going to be. It's in there somewhere. Well, anyway, Kairos works on the same principle. You can have many programs in memory at once, and each program is executed for a limited number of instructions and then suspended, so the runtime stops and exits and stores the state, stores what the next opcode was or any kind of variables that it needs to preserve, and runs the next program in the list. And the more programs you have in memory means that what's happening is that each program is getting less and less time, so it appears to slow down. So anyway, but getting back to where I was with this, all this is how 165 works. The process here with source code moves in, it's phrased into bytecode, and then that resulting bytecode there is converted into VM bytecode, and then the VM is started up if there's no syntax errors or errors, and given that chunk of code, and the code either works or it doesn't, But there's still some baggage from how it used to work in this process in here. Data statements actually are not part of the system at the moment. I've noticed that. I thought they were actually, but that's still there to be done. and we need a way of initializing the string information better. It's kind of important that's done, and done well, so I can actually do it once and then hopefully just never do that stuff again. Because what I'm obviously thinking about here is, once this thing is the compiler bytecode blocks and all the tables associated that are built up into the VM bytecode, which is one giant table, that I can pass that to translators, and as long as they understand the instructions, understand the structure of the data, we can have them converting PB into other things like the PlayBASIC to DLL stuff. That converter was actually made will be much easier to write, maintain, and update, because it'll have one format. The current version of it is so rigidly tied to how 164 works. Then it means that you really have to update it, put a lot of work into updating it each time you bump up PV, change anything internally. Pretty frustrating. Anyway, so getting beyond that that's the mundane conversion crap I've been talking about for probably 18 months. I wish it would go faster, but just the amount of time that I have now is, the last few years it's been getting less and less time. One thing I have been looking at though is looking into retro video games. And it's like a rat's nest. When you start looking on YouTube, you find all kinds of weird stuff. Well, the reason I was doing that, I was looking at what kind of series that we want to kick off. I want to do whatever we choose to do. I've kind of made this decision, I guess. The first one will be a retro shooter. I guess something along the lines of not Space Invaders. Yeah, everyone knows Space Invaders. Yeah, it was 1980. I've got everything but the video game. Well, there you go, Space Invaders. Hopefully people have seen this thing. There's other ones like Galaxian, which I like as well, which is it's not 1980. Yeah, there is. Just have a quick look at that. Galaxians is pretty cool because it skipping ahead. Hopefully stuff captures. This is why I'm testing this. Hope the volume's not too bad. But you've got not just your regular characters flying left to right. You've got characters bombarding the player. So a fair bit's going on in that. I'll just turn the volume of that off. Okay, so another one I like is Galaga. Or Gallagher, it might be pronounced by some people, I don't know. Our Australian accent kind of kills most things. Let's look at that one there. Yeah, it's booting up. With this particular game, what happens is that the convoy flies on and then moves up to the top, and then once all of the ships are on screen, it pretty much becomes Galaxian, but it has a bunch of neat little sort of ideas that are extensions of Galaxian. Now, these are kind of obvious ones. by shoot 'em ups, I also mean things like what's one that comes to mind? I mean, Swiv is a classic Amiga game. It's not actually a coin-op. It's a vertical shoot 'em up, but the rules are generally much the same. You've got this, you can fly a character or drive in this one. I'm just going to scoot through, get to some gameplay. So the character's controls and what's actually the player's doing are basically the same as what we are doing when we do Space Invaders, or we do Galaxian and Galaga, those kind of things. The only difference is we now have a much more interesting backdrop. We don't have the infinite kind of star field that we kind of see in classic games. Just bump that up in screen size there a little bit. Apologies if it's pretty low quality, but very cool old game. There's lots of these kind of shoot 'em up games. They all have the same principle. You'll notice that the sprites, some sprites have interactions with the background, and some things are aligned to the background. But generally, the gameplay is going on, which is completely unrelated to the background, and most of these games work like that. So we could do something like this too. That's all I'm saying. I haven't actually got one in mind. I think our initial one will be something that's quite simple. Also, we'll try and do the Galaga, Galaxian kind of thing. We'll make a little hybrid. We'll come up with a design document. We'll sit down in our Paint program and come up with some basic ideas about what's going to happen. Give ourselves some notes, and then try and build the code that produces that game. Don't know how it's going to go. Don't know how long it's going to take. Who knows? It could be over in a day, or it could take 3 months. But we will write the thing on. We'll get to a point where it's at least a playable prototype. Not necessarily a finished, polished game, because I just don't have time to do that. But you'll have all the source code updates there. You'll be able to go through, pick them up, play around with them, and if you follow through the tutorials, well, I wouldn't even call them tutorials. It's going to be just me chatting away while I'm making this thing. Hopefully you're picking up things, how I'm approaching certain problems, or I'll probably talk through certain problems as we're going through them. We might deliberately make some mistakes, show why it's not a good idea to do certain things, why it's a good idea to approach certain problems from a different perspective. But there's a lot to it. It's one of the most difficult thing about doing PlayBASIC is actually it's not making it. Making it's actually easy. Teaching this stuff to people is very difficult, because everyone has different aspirations about what they should get out of this thing. I'm looking at the thread here that it's on the board about wanting some ideas, and Steve's given some really good feedback here as well. I love the idea of making a platform game at some point and doing that live on camera. Got some other videos down here of Galaga 3 apparently, but yeah, I remember seeing that coin up at the Melbourne show and never anywhere else. So I don't know what happened to it. Okay, apologise for our rambling blah 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 stuff on today, but just really testing the recording on this system. Hopefully the audio quality is coming out reasonable. Hopefully the captures not dying when we watch our videos or run PlayBASIC programs, those kind of things, which is important if we want to do long captures of other things. Thanks for watching, and I'll catch you some other time. Bye.